So we've spoken a little bit about our translations and the processes which we apply. So state in words the transformations that are taking place to begin with. So we can see we've got the 4 at the front, the 2 inside the function, and the negative pi on 3 translating left-right. So the 4 at the front, multiplying the whole function by a value of 4, so it's dilating by a factor of 4 from the x-axis. The 2 inside the function, well, don't forget that the factor we multiply by is actually x on n. So to get a 2 inside the function, we must be dividing by a half. So we're multiplying by a factor of half from the y-axis. And then we can see our translation of pi on 3 units to the right is exactly that, pi on 3 units in the positive x direction. To sketch the graph, identify my period and amplitude first up. So my period is pi and my amplitude is 4. So we can see perhaps, what have we got? We've got a cos graph. So the blue function, the blue graph initially is my basic graph. Yeah, there's my y equals 4 cos 2x. And then I'm just looking to translate everything pi on 3 units to the right. So just to make life a little bit easier, what I decided to do was write all my key intercepts in terms of 12. I'm shifting pi on 3 and my intercepts or my axes was labelled in sort of quarters and halves. So I've turned everything into pi on 12 units. So pi on 4 is 3 pi on 12. A half pi is 6 pi on 12. And now I just now to move everything 1 unit or 1/12, 4/12 to the right. So we can see up here, my intercept at 0 initially, I'm going to shift it 4 pi on 12 to the right, okay? If I start from the left, this point up here, okay, at negative pi is now 4 units to the right, which is at negative 8 pi on 12. So I've added 4 on 12. My intercept here at negative 9 on 12 has moved 4 to the right, which is now at negative 5 on 12. So just move every point 4 pi on 12 to the right. Okay, and then that also gives me the axes. When I move left and the axis intercepts, I should say. All right, so this intercept here at 3 pi on 12, I've moved it 4 to the right, which makes it now, at negative 3 pi on 12. It's now got an intercept at pi on 12. This intercept here at 3 pi on 12 has moved 4 to the right, which is now at 7 pi on 12. So I've just shifted everything 4 pi on 12 units to the right. And then redrawn that, obviously in yellow. Identify endpoints, really important. So we can see down here how I've done that. I've substituted pi into the equation. Pi minus pi on 3 is, 3 on 3 minus 1 on 3 is 2 on 3 times 2 gives me 4 pi on 3. Cos of 4 pi on 3 is the same as cos of pi on 3. I've just got to check the quadrant I'm in. And in 4 pi on 3, I'm in the second quadrant, so I get a negative answer. Oh, I left the negative sign off, didn't I? And so my y value at x equal to pi is negative 2. And it's going to be the same at 0, which is a period later, and also at negative pi. All right? So take it a step at a time. Really encourage you to do the period and amplitude in one cycle, and then in horizontal and vertical lifts you could do even independently. Okay? Bit more graph sketching. Again, sketch the graph of 5 cos x plus pi on 4 plus 3. State the period and the amplitude. I think I was initially going to get you to do the transformations, but they're reasonably straightforward. Identify the amplitude, identify the period, and so again you can see there in blue, I've got one cycle of the cosine graph. All right, so halfway mark at pi, quarter of the way at pi on 2, 3/4 of the way at 3 pi on 2. And then from there, what are we doing? We're just moving everything up 3 and to the right. All right, so what I've done first is if I get the green texture back, is I've decided to move all my points pi on 4 to the left, isn't it? So that axis there goes pi on 4 units to the left. At pi on, instead of being at pi on 2, I'm back to pi on 4. The turning point down there at pi moves 1 unit to the left, 3 pi on 4. And to give me an idea, pi on 4 units is one big square, isn't it? So one big square is pi on 4 to the left. All right, so that was easy. I just have to move each dot to the left. So instead of being, where am I? Instead of being at 3 pi on 2, I'm at 5 pi on 4. Instead of being at 2 pi there, I've come across to the right. So then what I've done, I thought, well, instead of drawing that line in green, I've shifted everything up 3 units now. So this point here, the turning point, instead of being down at -5, it's now 3 units up, which is at -2. My horizontal line is probably the first thing I put in. So I've shifted the whole axis up 3 units. So now all these intercepts, I might use a different colour, that intercept now is there. This intercept that was going to be at 5 pi and 4 is now up here. Yeah. So I just move everything up, the units that I require, and then again, just connect the dots. So I guess going over the top, there's my cycle. Yeah, and now I've just got to extend it to make sure I've got it. Well, actually I've got 0 to 2 pi. Extend it to make sure I cover the 0 to 2 pi. So again, put the endpoint in at 2 pi. Cos of 2 pi plus pi on 4 is the same as cos of pi on 4. Cos of pi on 4 is root 2 on 2. So 5 times root 2 on 2 plus 3. So it's a messy, there's certainly a messy endpoint, but we should label it. On the left-hand side, the domain is at 0. So let's grab an eraser pen and let's just get rid of those points there, yeah? And we've got it labelled. Better. And that point up there is at, what did we say, at 0, 5 root 2 plus 3. Okay. So there's a graph. We've stated the transfer. No, we didn't have to state the transformations. We've stated the period and the amplitude. All right. Keep moving. State the transformations. The transformation is defined. State the equation of the image of the curve under this transformation. So it's just our matrix transformation, but we're applying it to a y equals cos 3x. So let's remember our process. Multiply my matrix out, -3x minus pi, 2y minus 2. Rearrange, that's what my ux and my uy are. So I have to rearrange it to get x equals and y equals. Yeah, because that's what my equation is. My equation is x and y. I want to find x dash and y dash. So x is equal to x dash plus pi on 3. Y is equal to y dash plus 2 on 2. Substitute into whatever equation I'm dealing with, which is y equals cos 3x in this instance. So there's my equation there. So then I've just got to rearrange. The 3 multiplying the 3 cancelled will give me an x plus pi. Multiply the 2 across, so I get a 2 out the front, and then I subtract 2 on the other side. So whilst I've written y, I guess you could argue that really we've sort of got, undo that, we've got x dashes and y dashes at this stage, haven't we? And then, you know, we could possibly argue it's a y dash and an x dash, but it doesn't matter. There's my new function. All right. What about this multiple choice question? We've got f of pi on 2 plus theta is equal to f of pi on 2 minus theta. So what does that mean? So pi on 2 plus theta is the same as pi on 2 minus theta. So if we consider pi on 2 plus theta, that's in the second quadrant. Pi on 2 minus theta is in the first quadrant. So the signs have to be the same. So the only function that has the same sign in the first and second quadrant is the sine function. Okay, so that's where I'm thinking at the moment. Let's have a look at the next pi on 2 plus theta, which again is the second quadrant, equals the negative of f of theta minus pi on 2. So theta itself is an angle between 0 and 90, and if I subtract 90, I'm going to get a value between, if you like, 0 and negative 90. So that puts me in the fourth quadrant. Sine is negative there, but the negative out the front makes it positive. So again, sine theta satisfies that function. And there's only one function in there with the sine x, so E must be our correct response. Finally, 11E, the graph is shown, state the transformations that the graph of f of x undergoes. So what changes has applied to f of x to become g of x? Well, straight away I'm thinking that this part of the graph there, between 0 and pi, has been stretched out to 0 to 2 pi. So we've multiplied by a factor of 2 from the y-axis, part 1. And secondly, this point that was a maximum of 2 is now a maximum of 1. So we've multiplied the y values by a factor of a half. So in other words, we've divided by a half from the y-axis. All right?